All right, so you guys need to review the yoga, osteoporosis, and the spine case study. I find this really interesting because it kind of weaves us back into injury being load greater than tolerance and the concept that yoga is kinder and gentler. Okay, so with any activity, you need to kind of assess the situation and figure out if it's right for your particular person, client, etc. So I want you to read this and then see if I can page down here. And answer these questions. Why would flexion postures of the cervical spine increase crust fractures in an osteopenic subjects? And so one is the flexion posture would be the loading, and the osteoporosis or osteopenic is dealing with the tolerance or the strength. Because what is osteopenia? Osteopenia, if you reviewed the bone, although I'm not sure it talked about it specifically, is considered low bone mass, not osteoporosis, but it's on its way to osteoporosis. So it has a lower bone mass, which suggests a lower tolerance, right? And so that now let's look at the loading side. So we know this person has a lower tolerance. Let's look at what flexion and neck extension does to the loading on the cervical spine. So my questions are, does neck flexion increase the torque or does neck extension increase the torque? And this concept basically goes back to the concept of the texting image that was on Piazza where the person was in spinal flexion. And what did that do to the quote load, or as we discuss it, torque on the spine? So let's look at the torque in neck flexion. So we're going to take like C3, C4 as the fulcrum, right? You always want the fulcrum. Center of mass of the head, I'm choosing it to be right here, acting down with gravity, pulling that cervical spine into flexion. And then the perpendicular distance from that force to the center of rotation or the fulcrum is the moment arm. So just take note of how the length of this moment arm. And then let's go and compare it to neck extension. Similar center of mass, or I tried to make it so. The head is the same, right? The weight of the head is the same. Center of rotation is the same. And what happened to that external moment arm? It decreased, right? So if you had a decreased moment arm, but the force was the same, the weight of the head was the same, the torque in neck extension would be smaller than the torque in neck flexion. Okay, let's just look at, see the moment arm large, smaller. So let's weave these together. So anterior wedge fractures are common in people with osteoporosis. And so my question to you is, would a flexor or an extensor torque contribute to this injury? And basically an anterior wedge fracture is if there's excessive compressive loading on the anterior side of the vertebral bodies, right? So there's increased compression that typically occurs when you are in flexion. If you have a low bone mass, it will crush. So when you are in flexion, there is a much greater load or torque on these elements of the spine than when you are in neck extension. So then my final question is, which exercises would you not recommend? Right? So basically you're looking for exercises that put you in excessive flexion and especially under load. So you might want to avoid this. You're in flexion and the weight of the body is acting down on the cervical spine. This is, you're still in flexion. It's only the weight of the head you're dealing with, but still the head is fairly large. And this, you almost have the whole weight of your body, especially if you go into a greater inversion acting down on the cervical spine.